Beneath the frozen surfaces of distant moons, far from the warmth of the sun, something extraordinary may exist. Vast hidden oceans, worlds of water in the darkness of space, worlds that could, possibly, hold life. For most of human history, Earth was the only known ocean world. Scientists once believed that beyond our planet, the solar system was frozen, dry, and lifeless. But in recent decades, spacecraft have revealed a different story. Under thick shells of ice, moons like Enceladus, Titan, and Triton hide global oceans of liquid water. These are not small pockets of moisture. Some of these oceans contain more water than all the oceans on Earth combined. They exist in places where sunlight cannot reach, where the surface is hundreds of degrees below freezing. Yet below the ice, tides, heat, and chemistry may create conditions suitable for life. This documentary will take you on a journey to the ocean moons of our solar system. We will explore Enceladus, the icy moon of Saturn that shoots water into space; Titan, a world with methane rivers, thick orange skies, and possibly a hidden liquid ocean; and Triton, Neptune's mysterious captured moon that hides active ice volcanoes and a possible sea beneath its crust. We will ask the questions scientists struggle to answer. How can liquid water exist so far from the sun? What forces keep these oceans warm? Could alien life be swimming in these hidden seas? And if life exists there, what does it mean for our place in the universe? Our journey begins not on Earth, but in the silent darkness beyond Mars and Jupiter, where the smallest worlds may hold the biggest secrets. Orbiting the gas giant Saturn is a small icy moon only about 500 kilometers across. Its name is Enceladus. At first glance, it looks like a frozen, lifeless world. Its surface is covered with ice, reflecting almost all the sunlight that touches it. Temperatures drop to below -200 degrees Celsius. Nothing about it seems alive, until you look closer. In 2005, NASA's Cassini spacecraft flew past Enceladus. What it discovered changed the course of planetary science. From cracks near the moon's south pole, plumes of water vapor, ice particles, and organic molecules were erupting into space. These geysers were stretching hundreds of kilometers above the surface, like icy fountains in the vacuum. Cassini flew directly through these plumes, collecting samples. Onboard instruments detected water vapor, methane, carbon dioxide, salt, and complex organic molecules. These are the basic ingredients for life. The discovery raised a profound question. Could Enceladus, a moon smaller than the state of Arizona, be home to alien life in its hidden ocean? Scientists now believe that beneath its surface, Enceladus has a global ocean of liquid water. This ocean is kept warm not by sunlight, but by tidal forces. As Enceladus orbits Saturn, gravity stretches and compresses the moon. This motion creates internal heat, keeping the water from freezing. At the bottom of this ocean, there may be hydrothermal vents. On Earth, such vents exist at the bottom of our oceans. They release hot, mineral-rich water and support entire ecosystems of bacteria, worms, and other unique creatures. These life forms exist without sunlight, surviving only on chemistry and heat from deep within the Earth. If similar vents exist on Enceladus, they could provide energy and nutrients for life. Simple microbes, similar to those found near Earth's hydrothermal vents, could survive there. Some scientists believe this makes Enceladus one of the most promising places to find extraterrestrial life in our solar system. Future missions are being planned to return to Enceladus. Some concepts involve flying through the plumes again, this time with more advanced instruments. Others imagine landing near the cracks, melting through the ice, and exploring the ocean below. If life is found, it would be one of the greatest discoveries in human history. Enceladus may be small, but it has become one of the most important worlds beyond Earth. A frozen moon that breathes water into space. A world that challenges our understanding of where life can exist. Farther out from Enceladus, still orbiting Saturn, lies the largest moon of the planet. Its name is Titan. Titan is bigger than the planet Mercury, and is the only moon in our solar system with a thick atmosphere. When you look at it through a telescope, it appears as a smooth orange globe, hiding its secrets beneath clouds of haze. That haze is made of hydrocarbons. The atmosphere of Titan is mostly nitrogen, like Earth's, but instead of oxygen, it contains methane and ethane. At the surface, temperatures are around minus 180 degrees Celsius. It is far too cold for liquid water to exist. But something else flows across Titan's surface. In 2005, the Huygens lander, built by the European Space Agency, descended through Titan's clouds. It passed through winds, fog, and layers of orange mist. Then it landed on a frozen plain, covered in icy rocks. Huygens sent back pictures of what looked like river channels and coastlines. This was the first time we saw a world beyond Earth shaped by rivers and lakes. But instead of water, the rivers are made of liquid methane. The lakes and seas are pools of liquid ethane and methane, stretching for hundreds of kilometers. On Titan, methane plays the same role that water does on Earth. It evaporates, forms clouds, rains from the sky, and fills lakes. Yet beneath Titan's icy crust, something even more extraordinary exists. Scientists believe that deep below the surface, there is an ocean of liquid water mixed with ammonia. Just like Enceladus, this ocean is kept warm by tidal forces from Saturn's gravity. This means that Titan is a world with two oceans, one of methane above ground and one of water deep below. Titan is not just strange, it is beautiful. Imagine standing on its surface. The sky is orange and hazy. The sunlight is dim, as if it is always twilight. Methane rain falls softly. You are surrounded by frozen landscapes carved by rivers, canyons, and sand dunes made of hydrocarbon particles. Some scientists believe Titan may be a glimpse into Earth's distant past. Before life began, Earth's atmosphere also contained methane, ammonia, and nitrogen. Titan may show us how the first organic molecules were formed. It may help us understand how life began on Earth billions of years ago. NASA is preparing a mission called Dragonfly. Instead of a rover, it will send a flying drone to explore Titan's surface. This flying machine will hop from one location to another, studying dunes, craters, and potential ice volcanoes. It will search for complex organic chemistry and signs of life. Titan is a world where it rains methane instead of water, where lakes are filled with liquid gas, and where a hidden ocean may hold the building blocks of life. It is one of the strangest and most intriguing worlds in our solar system. Far beyond Saturn, past Jupiter's storms and Mars's deserts, lies a world colder than any place on Earth. It orbits the distant planet Neptune. Its name is Triton, and it is one of the most mysterious objects in the solar system. Triton is not like most moons. It orbits Neptune in the opposite direction of the planet's rotation. Scientists call this a retrograde orbit. This means Triton was not born around Neptune. It was captured, most likely a dwarf planet from the Kuiper belt, pulled in by Neptune's gravity billions of years ago. Its surface is made of frozen nitrogen and water ice. Temperatures on Triton drop to around minus 235 degrees Celsius. That makes it one of the coldest known places in the solar system. Despite this extreme cold, Triton is alive, not with animals or plants, but with activity. In 1989, NASA's Voyager 2 spacecraft flew past Triton. What it saw stunned scientists. Dark geysers were erupting from the surface, shooting nitrogen gas and dust 8 kilometers into the sky. These are not volcanoes of lava. They are cryovolcanoes, volcanoes of ice. Beneath Triton's surface, sunlight warms dark patches of frozen nitrogen. Gas builds up and explodes through cracks, creating icy plumes. This means that even at the edge of the solar system, Triton is not a dead world. But there may be more. Scientists now believe that Triton, like Europa and Enceladus, could hide a subsurface ocean. The heat from its interior, created when it was captured by Neptune and stretched by tidal forces, may have melted water ice deep underground. This ocean would be buried beneath a thick crust of ice, possibly 100 kilometers deep. It would be trapped in darkness, warmed only by tidal energy and radioactive elements in its rocky core. yet this may be enough for liquid water to exist. Triton also has a thin atmosphere of nitrogen with traces of methane. Winds blow dark particles across its icy surface, creating streaks and patterns. Its surface is relatively young and smooth, suggesting constant renewal. What makes Triton even more intriguing is its future. Over millions of years, it is slowly spiraling closer to Neptune. One day, it may be torn apart by gravity, forming a ring system around Neptune, just like Saturn's rings. But before that happens, humanity hopes to return. NASA has studied a mission concept called Triton. It would send a spacecraft to fly by Triton, map its surface in detail, measure its magnetic field, and search for signs of a hidden ocean. Triton is a world of paradoxes. It is frozen and yet active. It is distant and yet full of motion. It may have an ocean buried beneath ice thicker than any glacier on Earth, and in that ocean, the ingredients for life could exist. Deep beneath the frozen crusts of Europa, Enceladus, and Triton, hidden oceans may be waiting in total darkness. They are worlds with no sunlight, no open skies, and no continents. Yet they may hold something extraordinary, the ingredients for life. On Earth, life does not rely only on sunlight. In the deepest parts of the oceans, far from the surface, creatures live near hydrothermal vents on the seafloor. These vents release hot water filled with minerals and chemicals. In complete darkness, bacteria use these chemicals to produce energy. Entire ecosystems form around them, with worms, crabs, shrimp, and fish. This discovery changed everything. It showed that life can begin and thrive without sunlight. All it needs is water, energy, and the right elements: carbon, nitrogen, hydrogen, sulfur, and oxygen. Europa, Enceladus, and Triton may have all three. Scientists believe that on Europa, the ocean touches a rocky seafloor. There, tidal heating from Jupiter could create hydrothermal vents, just like those on Earth. Warm water would rise through cracks in the ocean floor, carrying minerals and energy. On Enceladus, the Cassini spacecraft found that its icy plumes contain water vapor, carbon dioxide, methane, ammonia, and complex organic molecules. These are the same building blocks found in living cells. Triton is more mysterious. No spacecraft has visited it since 1989. But if it has a liquid ocean beneath its ice, heated by tidal forces and radioactive decay, it could be another candidate for life. But how do we explore oceans hidden under kilometers of ice? This challenge is one of the greatest in the history of space exploration. Humanity is preparing to return to the outer solar system, not just to observe, but to search for answers hidden beneath ice and darkness. The most ambitious mission begins with NASA's Europa Clipper. It is scheduled to launch in the middle of the 2020s. After traveling more than 600 million kilometers through space, it will enter orbit around Jupiter. From there, it will perform dozens of close flybys over Europa. Its instruments will scan beneath the ice using radar, study the thickness of the frozen crust, measure the salt and minerals in the surface, and search for faint traces of water being released into space. If Europa truly has a global ocean, Europa Clipper will tell us how deep it is and how active it might be. At the same time, the European Space Agency has launched a mission called JUICE, which stands for Jupiter Icy Moons Explorer. It is now on a long journey toward the Jovian system. It will study Europa as well, but it will also focus on Ganymede, the largest moon in the solar system. Scientists believe that Ganymede may also hold a buried ocean beneath its icy surface. JUICE will eventually orbit Ganymede itself, becoming the first spacecraft to orbit a moon other than Earth's. But the search for life does not stop there. NASA is also preparing a mission to Saturn's largest moon, Titan. It is called Dragonfly. Instead of a rover, it is a flying laboratory, a drone capable of lifting off and landing on Titan's surface over and over again. Titan is the only moon in the solar system with a thick atmosphere. It has rivers and lakes on its surface, not of water, but of liquid methane and ethane. Dragonfly will study the chemistry of this alien world and search for the first steps of life. the chemistry that may have existed on early Earth. Scientists are also designing future missions to Enceladus. One proposal is a spacecraft that would fly through its icy plumes, collecting frozen ocean particles and analyzing them for signs of life. Another concept goes even further. It would land on Enceladus, study the ice, and perhaps one day drill down into the frozen crust to reach the sea below. Farther away, orbiting Neptune, is Triton. It is distant, cold, and largely unexplored. Only one spacecraft has ever visited it, the Voyager 2 mission in 1989. Scientists want to return. A proposed mission called Triton would fly past Triton, map its surface in detail, study its nitrogen geysers, and search for evidence of a hidden ocean beneath the crust. These missions are not just scientific projects. They are our first real steps toward answering one of the oldest questions in human history. Are we alone in the universe? If life exists in the dark oceans of distant moons, then life may not be rare at all. It may be everywhere that water, energy, and chemistry come together. If we discover even a simple microorganism on one of these moons, it will answer one of the greatest questions in science. Are we alone? If life can begin in a hidden ocean beneath ice, then life could exist in billions of places across the galaxy. Not only on planets like Earth, but on moons orbiting giant planets, under ice caps, or deep within oceans of distant worlds. It would mean that life is not rare. Life is natural. It emerges wherever the conditions are right. But even if we find no life, these worlds still matter. Studying them will reveal how oceans form in space, how planets evolve, and how worlds far from the sun can stay alive. Life on Earth taught us an important lesson. Life does not always need sunlight, warm air, or green forests. Life needs two things above all: liquid water and energy. If these are present, life can find a way. On the ocean floors of Earth, far from sunlight, scientists found towering structures called hydrothermal vents. They release hot water rich in minerals. Around them, life thrives. Giant tube worms, crabs, shrimp, and bacteria live in total darkness. They do not rely on sunlight. They survive using a process called chemosynthesis. Instead of using light, they use chemicals like hydrogen sulfide to create energy. This discovery changed how we look at life in the universe. It means that even on worlds covered in ice and darkness, life may survive at the bottom of their oceans, near underwater volcanic vents. If life exists on Europa or Enceladus, it may not be large creatures. It could be simple microbes, similar to bacteria on Earth. They might float in the salty water, feed on minerals, or gather around warm fractures in the seafloor. But scientists also imagine more complex possibilities. Could there be small shrimp-like creatures swimming near hydrothermal vents? Could there be organisms with transparent bodies that glow in the darkness like deep-sea creatures on Earth? These are questions no telescope can answer. Only a mission that enters the ocean can. Life could also be very different from Earth. On Titan, surface lakes are made of liquid methane, not water. Some scientists wonder if life could use methane instead of water. It would be a form of life unlike anything we know, built from different chemistry, breathing different gases, living in bitter cold. Triton also raises deep questions. If its ocean exists, it might contain ammonia mixed with water, lowering the freezing point. Could life survive in an ocean like that? We do not know. But if life exists there, it may not resemble anything on Earth. Even if we only find fossils or chemical traces of life, it will be one of the greatest discoveries in human history. It will mean life is not unique to Earth. It is a natural part of the universe. Life on Earth taught us an important lesson. Life does not always need sunlight, warm air, or green forests. Life needs two things above all: liquid water and energy. If these are present, life can find a way. On the ocean floors of Earth, far from sunlight, scientists found towering structures called hydrothermal vents. They release hot water rich in minerals. Around them, life thrives. Giant tube worms, crabs, shrimp, and bacteria live in total darkness. They do not rely on sunlight. They survive using a process called chemosynthesis. Instead of using light, they use chemicals like hydrogen sulfide to create energy. This discovery changed how we look at life in the universe. It means that even on worlds covered in ice and darkness, life may survive at the bottom of their oceans, near underwater volcanic vents. If life exists on Europa or Enceladus, it may not be large creatures. It could be simple microbes, similar to bacteria on Earth. They might float in the salty water, feed on minerals, or gather around warm fractures in the seafloor. But scientists also imagine more complex possibilities. Could there be small shrimp-like creatures swimming near hydrothermal vents? Could there be organisms with transparent bodies that glow in the darkness like deep-sea creatures on Earth? These are questions no telescope can answer. Only a mission that enters the ocean can. Life could also be very different from Earth. On Titan, surface lakes are made of liquid methane, not water. Some scientists wonder if life could use methane instead of water. It would be a form of life unlike anything we know, built from different chemistry, breathing different gases, living in bitter cold. Triton also raises deep questions. If its ocean exists, it might contain ammonia mixed with water, lowering the freezing point. Could life survive in an ocean like that? We do not know. But if life exists there, it may not resemble anything on Earth. Even if we only find fossils or chemical traces of life, it will be one of the greatest discoveries in human history. It will mean life is not unique to Earth. It is a natural part of the universe. For thousands of years, humanity has looked at the night sky and wondered if we are alone. We built telescopes, launched spacecraft, and crossed the emptiness of space searching for answers. Now, for the first time, we are closer than ever. Beneath the frozen surfaces of Europa, Enceladus, Titan, and Triton may exist vast oceans older than human history. Oceans that move in darkness. Oceans that touch alien sea floors, warmed by tidal forces and ancient heat. Oceans that may carry the chemistry of life. These moons remind us that life does not need sunlight, forests, or blue skies. It needs water, energy, and time. And in the cold outer worlds of our solar system, nature has quietly provided all three. Whether life exists there or not, these missions will change how we see the universe. If we find life, even a single living cell, it will prove that life is not rare, that it is not limited to Earth. It will mean that the universe is alive in places we never imagined. And if we do not find life, the search still matters. It will show us the limits of biology, the origins of oceans, and the forces that shape distant worlds. It will teach us how planets live and how they die. It will teach us more about Earth by studying worlds that are not Earth. Exploring these moons is not only about science, it is about identity. It is about who we are as a species. We are explorers. We cross oceans. We climb mountains. We reach for the unknown. One day, perhaps centuries from now, humans may stand on Europa's frozen plains. They may dive into the oceans of Enceladus in submarines. They may sail methane seas on Titan beneath an orange sky. They may live in ice caverns on Triton and watch Neptune rise above the horizon. It will not be easy. It will take courage, technology, and time. But this is how civilizations grow, not by standing still, but by stepping into the dark and turning it into light. In the end, these icy moons are more than just distant orbs in the night sky. They are mirrors. They reflect our deepest questions. Where did we come from? Are we alone? And how far can humanity go? The answers may be hidden beneath ice, in pitch-black oceans, waiting for the first probe, the first submarine, or the first human to arrive. Until then, we will keep searching. We will keep listening. And we will keep dreaming. If this journey into the hidden universe inspired you, make sure to subscribe, stay curious, and join us again as we explore the greatest mysteries of space, time, and life itself.